And third information is, when you open the link, soon that please turn on the video, because it is very difficult for our technical department to remind you again and again to turn on the video. They are doing their work best as best as possible. Please cooperate with them. And fourth one is, please place the mobile with a comfortable distance and such that your face should be visible on the screen. Next, okay, dear students, now coming to our lesson. So as you all know that in yesterday's class, we have come to know what are the chapters that we are going to learn in this academic year, right? And from those chapters, we have also come to know that in those, no chapter all chapters are very familiar to you, and using your previous knowledge, the concepts that are given in this academic year are going to be discussed. Next, among those chapters, we commence the very first chapter, that is number systems. With respect to that, we got some of the basic information as well. It may be the number, numerals, digits, prime number, composite number, even number, odd numbers, right? Even with respect to all these, yesterday I had given you the worksheet. I really appreciate all the students who have submitted your worksheets in time. And do remember, every day worksheet will be sent exactly at 5:30. And please do finish within 7 or at most 7:30 and send those worksheets to my WhatsApp number. And for any clarification from 7 o'clock, I'll be free. From 7 to 8, it is your doubt clarification class. Make use of that class. Okay. So with that instruction, let's continue the chapter, number system. In this chapter, the main concept is discussing about different types of numbers. In those, the first two were discussed, right? One is natural numbers. Second one is whole numbers. All the counting numbers like 1, 2, 3, 4 and so on, they're all natural numbers. Those counting numbers, including 0, are called whole numbers. And one of the important statements with respect to these two is all natural numbers are whole numbers. But converse of this statement is not always true. Means all whole numbers cannot be considered as natural numbers, because in whole numbers 0 is there. 0 is not a natural number. Now let's move on to the next one. Next type number. Look at it. Don't go for copying that. Here I'll write the numbers 1, 2, 3, 4 and so on. Could you tell what type of numbers are these? With respect to different types of numbers, we have already discussed.
Natural numbers. Natural numbers.
These are all natural numbers.
Natural numbers.
Now I go for including 0. Now what do you call all these numbers?
Whole numbers.
Whole
numbers. Whole numbers.
Now I'm going to write the negatives. Can we take the negative of 0?
No, sir.
No, sir. No, sir.
Yes, because 0 has no sign. For remaining numbers, we can take their negative. The negative of 1 can be written as -1. Negative of 2 can be written as
-2.
Similarly, -3 and so on. These numbers can also be written as 0. Here we have positive 1 and negative 1. Let me write them together. It can be written as like this. And is to be read as plus or minus 1. Next, plus or minus 2, plus or minus 3, and so on. Observe it. Dear students, please don't go for writing anything. Do follow my instructions correctly. Here we have the whole numbers with their negatives. Then what do you call such numbers?
Integers.
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 You are right. Whole numbers, including their negatives, are called integers. Please write the third one. Integer. Integers. Write down the definition as well. Right. All whole numbers, including their negatives. Their negatives are called integers. All whole numbers, including their negatives, are called integers. Hope that you have written. You can also define this as the natural numbers, including their negatives, along with 0, are called integers. The natural numbers and their negatives, including 0, are called integers. And these are examples for integers. You may write ... Just put some comma and write -3, -2, -1, comma 0, 1, 2, 3, and so on. Can also be written as, right, or 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on. Written. Here you all know that the collection of natural numbers is denoted by the capital N. Collection of whole numbers is denoted by the capital letter W. Then how do you represent the collection of integers?
Z.
Capital
Z.
Z. Then okay.
Capital letter I.
Okay.
Z.
Dear students, see the word natural number starts with the letter N. Whole numbers start with the letter W. Integers start with the letter I. Can we use the letter I to denote collection of integers?
No, sir. No, sir.
No, sir.
No, sir.
Yes, sir.
I will be used. Natural number N, whole number W, integers I. Then some of you said that Z also. How did you come to know Z is also one of the symbols used to represent integers?
Or we have read in textbook.
Very good, very good. As you have read the textbook, you have come to know even Z is also symbol used to represent integers. Have you thought that why Z is to be taken to represent integers? The first letter is I. I is correct one. For natural number, N is correct. Whole numbers, W is correct. Then why Z should be taken?
It is came from German word.
So
Yes,
it's come from the word Zalina, which means counting.
Zalen,
German.
Then
to count. Oh, okay, you are right. Listen to me. You said that the letter Z has been taken from the German word Zahlen. Don't copy, just look at the word. Zalen. Z-A-H-L-E-N. The meaning of Zalen is, it is to count. But dear students, you just think about it. To count. For counting numbers, will you go for using negative numbers? No. Then this letter could have been taken for natural numbers, no? Because the counting numbers are 1, 2, 3, 4, and so on. How did you accept Z is a symbol to represent integers? Is it not? That question should come into your mind. Right? Dear students, I want your response.
Okay, sir.
Yes, sir.
Yes or no?
Yes, sir.
Okay.
Yes.
That is why I always be telling you that read the textbook and mark where you come across the doubt, and that doubt can be discussed in the classroom so that everybody will also come to know. Okay. Now I'll tell you that why the letter Z should be taken. Dear students, in your previous classes, you have learned about distance, forward distance as well as backward distance. Imagine that a man is walking from a point. I call that point as A. He moved towards the right side around 5 meters. Then he comes back by 3 meters. And his final position, I'll take this as B. Could you tell what is his distance from his initial point, initial position?
8 meters.
2 meters.
2 meters.
2 meters. Right?
2 meters.
Why did you get 2 meters?
5 minus 3 is equal
5 minus 3 is 2.
5 minus 3 is equals to
2.
because
Yes.
when
Listen here, your students. In forward movement, we will go for choosing the positive numbers. See that if a person has moved 5 meters, means it is plus 5. Then backward movement, he has covered 3 meters. So for backward movement, we will go for taking the negative numbers. See, both positive numbers are used for counting, negative numbers are also used for counting. Then finally we got 2 meters as the right answer. Is it not? So that is why we will go for using the letter Z to represent integer. Hope that you all have understood.
yes, sir.
In forward movement and backward movement, we will consider both positive and negative numbers for counting. That is why we use the letter Z. Write in note that the letter Z, first point, the letter Z has been derived from, has been taken from German word Zalen, Z-A-H-L-E-N. Let it be in 2 inverted commas. Zalen, which means to count. Which means to count.
Sir, what is that, sir, after the letter Z has?
Yes?
E-
Z has been derived from German word Zahlen, which means to count. Okay, dear students, just come across the examples for integers. Look here, you may stop writing, observe the board. Here, what do you call 1, 2, 3, 4, and so on?
Positive.
Positive integers.
Integers.
They are all positive.
Positive integer.
Okay. And minus 1, minus 2, minus 3.
Negative
they are all-
Negative integers.
Yes. Now I'm going to write only the numbers 1, 2, 3, 4, 5, and so on. What do you call these numbers with respect to integers? You said that positive integers. Other than that, can we use any? These are all
numbers, sir.
natural numbers.
Natural numbers.
Okay. Integers include natural numbers. Can we say that all natural numbers are integers?
Yes,
Yes,
sir.
sir. Yes, sir.
Got it? Now, with the 0, if you go for taking with 0, these
Whole
are
number.
whole numbers. All whole numbers are there in integers. Hence, we can also say that all whole numbers are integers. There are.
Yes,
The
sir.
purpose of this statement is not true. Okay, look at the word. Look at the word. Look at the word. You said that 1, 2, 3, 4, and so on. There are positive integers. And minus 1, minus 2, minus 3, and so on. There are negative integers. Then what do you call these? 1, 2, 3, 4, 5,
Whole
6.
numbers.
Whole numbers.
I'm not asking you
Whole
the
numbers.
type of the numbers. I'm not asking you the type of numbers with respect to integers. These are positive, these are negative. 0 is neither positive nor negative. My question is, then what are these?
Rational.
Numerals.
Huh?
Numerals.
Rational numbers.
Positive natural numbers.
Once I repeat, these are positive integers. And these are negative integers. Where 0 is neither positive nor negative. Then what do you call these with respect to integers? Don't say whole numbers. Don't say rational numbers.
Rational numbers.
Positive integers only, sir.
Integers, sir.
Then 0 is not a positive, no? Neither positive nor negative.
Digit.
Okay, myself only with that.
Whole numbers.
These numbers are called
Rational.
non-negative integers. These are called non-negative
Non-conjugative.
integers. You have come across non-negative integers, no? Is it not?
Yes, sir.
Yes, sir.
Non-negative integer means except negative numbers, you have to take remaining. Except negative. So 0 will also be included. So note down that as second. Non-negative integers are non-negative integers are 0, 1, 2, 3, and so on. Okay, student. Now we are moving to the next one. Just listen to me. For this, you have to recall your previous year concept. Could you tell the mathematical concept in which a part is taken out from the whole?
Fraction.
Fraction.
Fraction, right? And we know that every fraction has two terms. What are these?
Numerator.
Numerator and
Denominator.
denominator.
One is numerator and another one is denominator.
Denominator.
Now, look at it. I write a number 5. Is it possible to express as a fraction?
No, sir.
No, sir.
Yes, sir.
Oh,
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
5 by 1.
Wait.
Yes, sir.
Wait. Abhishek.
Hello, sir.
Is it
One
can
minute.
be written
Wait a
as
minute, sir. Wait a minute.
fraction?
Wait a minute. Wait a minute. Everyone, I am requesting, dear children, for your kind information, listen carefully. So whenever sir will ask a question, so whenever you are going to answer it, after answering, unmute your audio. Okay, we are provided a chance to speak. So whenever you wanted to answer, you can unmute and you can answer it. Afterwards, please mute your audio. Don't keep it on. Don't keep it on. Please mute your audio after answering. Sir, continue, sir.
Okay.
Thank you.
Right. To say that 5 can be expressed as a fraction. Yes, one student has already given the answer. I'll write the same. It can be written as a fraction like this: 5 by 1. Is it possible to write it in other numbers?
5.
5 is to be written as 5 by 1.
Yes, sir.
Yes, sir.
10
The other
by
way
2.
of
25 by 5.
So
in
10 by
fraction.
2.
10 by
25 by
2.
10
5.
by 2.
Very good.
25 by
Is 10 by 2. See that again. 10 by 2 is 5.
5.
Okay, even you have learned about it. That is
3 by 5.
3 by 2 is obtained by multiplying 2 to the numerator and denominator. A fraction which is obtained by multiplying same number to the numerator and denominator is an equivalent fraction. So this is an equivalent fraction. If it is so, can it be written as minus 10 by minus 2?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, that's you are right. It is 5 is written as minus 10 by minus 2 because here minus and minus get cancelled. On simplification, again you will get 5. See that a number is expressed as a fraction. I take this fraction as p by q. Got it? And observe the numbers in place of p. Here 5, here 10, here minus 10. Are these integers?
Yes, sir.
Yes.
Yes, sir.
1, 2,
Yes, sir.
minus 2.
Yes,
They
sir.
are all integers.
Integers.
Can I say that
Yes, sir.
P, wait. Can I say that P and Q are integers?
Yes,
Sir.
Yes, sir.
Yes, sir.
Yes,
Yes, sir. Yes, sir.
Yes, sir.
Observe Q. Look here we have positive integers. Here we have a negative integer, but there is no 0. So that is one of the condition. Q is not equal to 0.
0.
Observe it. This is the number which has been written in the form P by Q, where P and Q are integers and Q is not equal to 0. Then what do you call such number?
Rational numbers.
Rational numbers.
Rational numbers.
Rational numbers, sir.
Yeah, please write the side heading. Fourth one, it is rational number. Rational number. Don't write the definition. Afterwards, I'll give you. Rational number. Written up.
Yes, sir. Yes, sir.
Tell the definition. Observe. A number which can be written or which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called a rational number. So this condition is must. It should be written in the, it can be written in the form P by Q, and P and Q must be integers and Q should not be 0. Dear students, do you have any doubt with respect to this condition?
No,
Sir,
sir.
why
No,
we
sir.
take, sir?
No, sir.
Why?
No.
Sir, Q, sir, why we cannot write 0 in the denominator?
Very good. Very good. This is what I expected. Why it should always be, why it should always not equal to 0. Q should not be equal to 0. Then you all may be thinking that what happens if 0 is there in place of Q? And why? See that 5 by 0. What is its value?
0.
0.
0. What is 0 by 5?
5.
5. 5. 5. 5.
0.
Here 0 it is wrong. Here what you have used 5, you said that is also wrong. Look here. 5 by 1, it is 5. When
Yes, sir.
5 divided by 1, you will get 5. When 0 is divided by any number, you will get 0 only. 0 by anything is 0. But anything by 0, like 5 by 0, it is undefined term in mathematics. So we write it is not defined. Got it? Yes, you are right, Shamita. Anything by 0 is undefined. 0 by anything is 0. Any number by 1, the number itself. Please do remember. Okay. Now you may go for writing the definition. Right. A number that can be written in the form of, written in the form P by Q. A number that can be written in the form P by Q would come up where P and Q are integers. P and Q are integers and Q is not equal to 0. Is called a rational number. A rational number. Example for rational numbers. Right. It is 0, -3, 5, 1 by 8, 10 by 3, and so on. Hope you have written. Mohita VG, do you have any doubt regarding the examples what I have given? Mohita, Manasa, Prerna, Lakshmi Sri, any doubt regarding the examples what I have given with respect to rational number?
No, sir.
No.
So
If-
can a negative integer come as a numeral and a positive come as the denominator? And
That is also. The condition is P and Q should be integers. Maybe positive integers, maybe negative integers, or one is positive and another one is negative.
okay.
Here, I have written 0. Is it a rational number?
No, sir.
No, sir.
No. Then have you written
Yes,
0
sir.
as an example?
Yes,
0
sir.
by 1.
0 by 1.
Not comes to rational number. 0
0
by
by
1.
Wait,
It's
very
neither
good,
a
very good. 0, it is a right example because 0 can be written as 0 by 3,
0 by
0
1.
by minus 11,
0 by 1.
0 by minus 11, so on, even 0 by minus 12. Okay, all these are written in the form of P by Q. P and Q are integers and Q is not equal to 0. Therefore, 0 is a rational number. Once I
We can write
repeat.
also, no, sir.
Yes,
We can write 0 by 1 also, no, sir.
you can write 0 by 1. 0 is a rational number because it can be written in the form P by Q as 0 by 1, 0 by 2, 0 by 3, 0 by minus 1, 0 by minus 2, and so on. But you cannot write 0 by 0. 0 by 0, it is also undefined term in mathematics.
So,
Yes.
is it compulsory to write by 1 in every example of rational numbers?
Is it compulsory to write?
0 by 1 or minus 3 by 1 in while giving examples of rational numbers?
No, not necessary. Not necessary. Just only for the explanation purpose I have written.
Okay, sir. Thank you.
Yes. Look here. So minus 3 is a rational number. 5 is a rational number because all these can be written in the form of P by Q with a condition. 1 by 8 is a rational number. It is already in the form P by Q. Similarly, 10 by 3 as well. Followed? Have you understood?
Yes,
Okay.
sir.
Yes, sir.
Now,
Yes, sir.
do you know what is the symbol that we use to represent the collection of rational numbers?
Capital letter Q.
Q.
Capital
Q, sir. Capital letter Q.
Capital Q. It should come R, no? For natural numbers, N. And for whole numbers, we have used W. Integers, we have used I. But why R is not used for rational number? Is it not? You can think now. You can also discuss with me. Sir, we can use capital R as the symbol to represent collection of rational numbers. Why it is Q only?
Sir,
Anybody?
R, capital letter R, it is used to denote a real number.
Oh, okay, that is real. But why here
Q comes
Q?
from
In the denominator, no, sir. P and
Quotient.
Q.
Quotient,
Ah.
sir.
Q means quotient, sir.
Okay.
Quotient.
Arushi, you are telling
Sir,
that
yes, sir.
Q is the letter taken from quotient. Why it should be taken from quotient?
So like it's dividing, no, sir. 1 by 8, 10 by 3. It's a division, no. So the product can be a quotient. So Q.
Product. On dividing, you'll get quotient. Very good.
Yes.
Very good. Very good. Observe, yeah? Your students, just observe the board. Here I'll write 40. Don't go for writing anything. Let us divide this 40 by 5. On dividing 40 by 5, you'll get 8. Right? 8 is what?
A quotient.
8 is quotient. Is it not? Or your word method like this. 40 should be divided by 5. 5 8s are 40. Remainder is 0. Then 8 is the quotient. So when you divide a number by another number, you will get a quotient. Hence, as the rational numbers are to be written in the form of P by Q, you get the quotient. Therefore, the letter Q has been taken from the word quotient. Have you got it?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Right. Note. First point is the letter Q comes from the word quotient. The word quotient. And please do write any number. I take a number as an integer as a. A by 0. What is a by 0?
It's a rational number.
Fine.
Rational numbers.
No, sir, no, Q can't be
Can
zero.
be
Q
defined,
can't be
sir.
zero. It's
Sir,
not.
Q cannot.
Sir,
Q can't be
cannot
zero.
be equal to 0.
Right? But my simple
Not
question,
defined.
please understand my simple question. What does a by 0 indicate?
Not defined.
Not being.
It is undefined term in mathematics, no?
Yes, sir.
So a may be any number. So I told you that any number divided by 0 is undefined. Please copy. Is not defined. Is not defined. The next one. Any number by 0. Sorry. 0 by any number.
Value is 0.
Its value is 0.
The answer will be 0.
You are right. You are right. My another question. What is 0 by 0?
Zero.
Is not
Zero.
defined.
Not defined.
Is not defined.
Undefined.
Not
Is
defined.
not defined.
Okay, okay.
Fine.
Not defined. Copy.
Yes, sir.
Dear students, I have one doubt with respect to this. That is 0 by 0. Could you clarify? Could you clarify?
Try, sir.
try, sir.
Nobody is opening the mouth.
Try, sir.
Okay. 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 Just observe it. Look here. Don't copy. Here I'll write the number 7. Numerator 7, denominator 7. Numerator and denominator terms are same. What is its value?
1.
10 by 10.
1.
1.
1, sir.
1, sir.
How many times you tell 1? Just observe. 11 by 11.
1.
1.
0 by 0.
0.
0.
Undefined.
Not defined. Not
Defined.
Not
Not
defined.
defined. Defined. Not defined. Not
Enough,
defined, sir.
Enough. Look, you started arguing. Observe. Use it. Look at numerator, denominator terms are there. Then we'll write that value as 1. Here numerator is 0, denominator is 0. Then it should be 1, no?
Sir.
No,
Doesn't
have value.
Doesn't have value, sir.
Yes, sir.
Very good. Very good. It is not equal to 1
2
because 0, as we know that it has no value.
value. Yes, sir.
Denominator, numerator and denominator. When nothing is divided by nothing, what you will get?
0.
It is
Nothing.
undefined.
Nothing.
You won't get anything. Nothing by nothing, nothing only. Okay. Let it be. Let us take that nothing as undefined. So hence 0 by 0 is undefined term in mathematics. Please do remember that. Okay. Look at it. I'll go for taking fifth one. And before going to fifth, just look here. Here, we know that 5 is a natural number. So, this natural number is there in rational number collection. Hence, we can say that all natural numbers are rationals. 0 and 5, both are whole numbers. So, they are also in the collection of rational numbers. All whole numbers are rational numbers. 0, -3, 5, they are all integers. Hence, we can say that all integers are rational numbers. So, remember this point. Okay. Next one. I won't go for telling. You only should tell what is that fifth one.
Irrational number.
Irrational numbers. Irrational numbers.
Irrational numbers.
Okay, right. Irrational. Irrational number. Dear students, I do not know what is an irrational number. Could you help me?
The number which cannot be written in the form of P by Q.
A number which cannot be written in the form of P by Q. That is
Improper fraction.
Improper fraction.
improper
improper.
fraction. Okay. But I am not understanding what you are not convincing me. I do not know the definition of irrational number. But I am taking help from your side. One student said that it cannot be written in the form of P by Q. But look here, I write root 2 as root 2 by 1. No? It is in the
Yes,
form
sir.
of P by Q. Then whether
So it's all are not integers. P by Q are not integers.
Condition is there. Look at P and Q should be integers and Q is not equal to 0. Of course, Q is an integer and is not equal to 0. Then P is not an integer. Hence, we can define irrational number as a number which cannot be written in the form of P by Q with the condition P and Q are integers and Q is not equal to 0. Clear up? So such numbers are called irrational numbers. So we can take few examples for irrational numbers as root 2, root 3. Can I take root 4?
No, sir, we can't take root
No.
4.
Sir,
We can't take.
root will be 2.
Root will be this 2.
Good. Root 4 is 2, which is a rational number. So 4 will not come. Root 5, 2 into root 3, many are there. And 2 into root 5 by 7. Just keep observing the examples what I have been giving. Another one, it is 2 plus root 3. 7 minus 3 root 2 by 4. All these are irrational numbers. Did you understand?
Yes, sir.
Yes, sir.
Once I repeat the definition, afterwards I'll go for writing. Listen carefully. A number which cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called an irrational number. So write the definition. Irrational. A number which cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called an irrational number, or just you may write irrational. Is called an irrational number. Examples. Go and write it with me. It is root 2, root 3, then 2 into root 5, 7 by 2 into root 11, 2 plus root 3, 3 minus 2 root 11, etc. These are all irrational numbers. Have you copied?
Wait, sir.
Yes.
1 minute.
You should go on writing with me so that you can finish earlier. And observe here, the collection of irrational number is denoted by which symbol?
I, sir, capital letter I.
Capital I, we have already used for integers now.
Yes. It is called irrational number.
It is Q dash.
Yes.
Yes.
Q. Then ask me a question that, sir, why you are going to use Q dash as a symbol for irrational numbers? Is it not?
Yes, sir. Yes, sir.
Open your mouth.
Yes, sir.
I'll tell you why. Dear students, in your previous classes, you have learnt about uncertainty, right? Nothing but probability. Have you learnt or not?
Yes, sir.
Yes, sir. Yes, sir.
If so, now you tell, how do you represent the probability of an event which happens? It is P of E, that is probability of an event which happens. Got it?
Yes,
And
sir.
what is this converse? That is the probability of an event which does not occur or which does not happen. It is P of E dash. Is it not? Many of you are mum, not opening the mouth, not giving the response.
Yes, sir.
Probability you have used. One example. See, when a coin is tossed, can we get one head? When one
No,
coin is tossed, can we get a head?
No, sir. You can get tails also.
So this
There may be head or tail. I am asking you, is it possible to get head?
Yes, sir. Yes, sir.
Yes,
No.
sir.
Okay.
Yes, sir.
Mike, another question. Is it possible when a coin is tossed, is it possible to get more than one head?
No,
No.
sir.
No, sir.
Is the event which does
No,
not
sir.
happen, right? So, okay. The probability of an event is which happens is P of A, not happens is E dash. This is the converse of the first statement. And observing irrational is a converse of rational. Rational number will be written in the form of P by Q.
P by Q.
Condition. Whereas irrational number cannot be written in the form of P by Q with a condition. Hence, it is to be represented as Q
Yes.
dash. Yes, students, did you understand?
Yes,
Yes.
sir.
Okay.
Yes, sir.
Okay. Now, observe. Just look at them. Here, I'll write some numbers. 1, 2, 3. We have already discussed about different types of numbers. What type of numbers are these?
Natural numbers.
Natural numbers.
Natural.
Natural numbers.
Yes. If I include 0,
Whole.
Whole
Whole
numbers.
numbers.
whole numbers. If I write their negatives,
Integers.
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 if I write in the form of P by Q,
Rational numbers.
Rational numbers.
Rational numbers.
it cannot be written in the form of P by Q.
Irrational numbers.
Rational numbers.
Rational numbers.
Yes, irrational numbers. Dear students, you can notice that in this collection, we have all rational numbers and irrational numbers, right? You know that all natural numbers are irrational, whole numbers, all natural numbers are rational, whole numbers are rational, integers are rational. So then, can we say that it is a collection of rational and irrational?
Yes, sir.
Yes, sir.
Then what do you call this collection?
Yes.
Real numbers.
Real numbers.
Real numbers.
Real numbers.
Real numbers.
Numbers.
Real number,
Numbers.
it may be rational or it may be irrational. Nothing but it may be natural, whole number, integers, rationals or irrational. So the collection of all rationals and irrational numbers is called real numbers. Real number, right? Sixth one. Real numbers, REAL, real numbers are just in the right number. Write out the definition. The collection of rationals, nothing but rational numbers, and irrationals is called real, or just a real number. Example, write the same. Here, 0 plus or minus 1, then 3 by 7, root 2, root 11, and so on. They are all real numbers. Written up? Written?
Yes, sir.
And the symbol that we use to represent real numbers
R.
R.
are.
sir.
R.
Yes, it is real, which includes all rationals and irrationals. When is irrational number used? Even to represent the number on the number line also, we'll go for irrational number. We'll go for using irrational numbers. We have a separate concept for that. I'll discuss. Okay, look here. Okay. Dear student, you are very familiar with many mathematical symbols. I'm going to write a symbol. You just tell what it is. Could you tell which symbol is this?
Belongs to.
Very good.
Belongs
The symbol is belongs to or belonging to. Don't write anything. Just look at them. We all know that all natural numbers are belonging to whole numbers. Can we write so?
Yes, sir.
Yes. All whole numbers
Yes, sir.
belonging to integers.
Yes, sir.
Yes, sir.
Yes, sir.
All integers belonging to rational. Right?
Yes, sir. Yes, sir.
Yes, sir.
Rationals are the reals.
Yes, sir.
Yes,
Yes,
sir.
sir.
Another statement. And all
Yes,
irrational
sir.
numbers are real numbers. Can we write so?
Yes, sir.
Yes, sir.
Yes, sir.
Copy. This is the symbolic representation of relationship among natural numbers, whole numbers, integers, rationals, and real numbers. Sir, in text, please. Once you send that message, I'll read.
Okay, sir.
Over.
Yes, sir. This is not mine.
Every day I've been sending the link for the class, right? And along with that link, a picture has been given. Have you noticed that?
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Will anybody tell what does it represent?
Some
What is that picture?
graph, circles, real numbers,
Okay.
and
No. In that picture, of course, oval shapes are there, circle shapes are there, then a rectangle is there. I'm not asking that. What does that whole picture indicates?
Collection
Real
of
numbers, sir.
real numbers.
Real number.
Real numbers.
Chapter
Real
name.
numbers.
Chapter name.
Enough.
Chapter name.
Enough. Of course, in that natural, whole numbers, integers, rationals, irrationals, reals are there. But my question is, what does that picture indicate? That picture will give us information regarding the relationship among all the different types of numbers. Look here. If I take the rectangle, copy, just observe. If I take the rectangle as real number, you all know that it includes both rational and irrational. See that? I'll take these two. It is rational Q and this is irrational Q dash, right? And we all know that this Q, that is this rational number, includes integers. Integers include whole numbers. Whole numbers include natural numbers. Hence, we can write this is N, this is W, this is I or Z, this is Q, and this will be Q dash. All together, it is real. Did you understand?
Yes,
Yes,
sir.
Yes, sir.
Yes, sir.
No need to copy, just it's an information. Now, we are moving to next important concepts related to these numbers. Let me rub this. Dear students, you have learned about number line in your previous classes, right? Now stop your activities. Let your attention be on my explanation. You are very familiar with the number line. You have used number line for different purposes in your previous classes as well. Maybe representing natural numbers, rational numbers, whole numbers and all. Even multiplication, addition, subtraction. Is it not? Yes or no?
Yes, sir.
Yes, sir.
And even you have learned that the mathematician who has introduced the concept of number line. Could you tell? Could you tell? He is Richard Dedekind, right? He is Richard Dedekind. He is the mathematician who introduced the concept of number line. So even we'll get more information about the number line in the forthcoming periods. Now, just I'll give you an information regarding number line. Look here, I draw a line, straight line, where arrow marks are shown on either side, which will give us information that the line can be extended to any length. Then somewhere else, I'll write 0. And you also know that the right side of 0 are to be taken as
Positive
numbers.
Positive numbers. Positive numbers.
Positive number. Here 0, here is 1, here is 2. With the unit distance I'm writing, here is 3, this is positive 4, positive 5, and so on. And left side of 0 are
Negative number.
Negative numbers.
negative numbers. Negative 1, negative 2, and so on. Here, could you tell, is there any number which is not rational?
0?
No. My question is there any number which is not rational?
Not rational.
No, sir. All are rational.
All are rational numbers. All are rational numbers.
Rational numbers.
All are rational numbers.
Rational numbers.
Look here. I take 0 as a rational number. Then 5 is also a rational number.
Yes, sir.
0 is a rational number. 5 is also a rational number. Now, in this number line, could you tell how many rational numbers are there between 0 and 5?
Infinite.
Infinity.
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 I'm asking you very simple question. Please understand that. With respect to this number line, you just don't go for telling
Four.
generally.
Four.
Very good.
Four.
You are right. Between 0 and 5, there are 4 rational numbers. Right? Now, between 1 and 3, how many rational numbers are?
One.
One, sir. One.
Between 1 and 4,
Two,
2 are there.
Two, sir.
2 and 3.
two.
Right? Now, look here. I take 0 as a rational number. 1 as a rational number.
Two, sir.
Wait. At
No
present,
rational numbers.
no rational numbers are there in this number line.
They are there, sir.
Wait. Please listen to me first. In this number line, I have not mentioned any numbers so that you can say that no rational numbers are there. Now, I'm going to mark the midpoint of 0 and 1.
0.5. 1 by 2.
5.
1 by 2. 1 by 2 is a rational number. Now, how many are there? How many are there?
One.
0 and 1.
1.
1 is there. Now, I'll write a rational number between 0 and 1 by.
1 by 4.
1 by
By
4.
five.
Very good.
1 by 4.
1
by 4.
1 by 5.
3 by 4.
3 by 4. Very good. And this, again, between 0 and 1 by 4, one number can be written. 0 and 1 by 2, one number can be written. So from all these, from these examples, we can say that between two rational numbers, there will be uncountable number of rationals are
Rational.
there. Dear students, did you understand?
Yes, sir.
First we took between 0 and 1, nothing was there. Then after that I included 1. Now after that, 2 more, 3 are there. Like that. If you go on writing just taking the midpoints, you'll get plenty of rational numbers. So from this, we can conclude that between any two rational numbers, there are uncountable rational numbers are there. Dear students, you all know that how to find out the midpoint of rational numbers, which you have learned in your previous class. You learned about how to find out the mean of the two numbers. If I take A and B are the two numbers, what is their mean?
A plus B by 2.
A plus B by 2. A plus B
Very
by
good.
Plus B by
A plus B by 2.
You are right. It is A plus B by 2, right?
yes, sir.
Just to recall the mean concept, it is sum of scores divided by number of scores. Similarly, here two numbers are there. Their sum is A plus. Number of scores, there are two numbers. Hence, A plus B by 2. Clear? So this formula can be used to find out just one rational number between two given rational numbers. Followed? If I suppose I want a rational number between 2 and 6. I want a rational number between 2 and 6. You may write either 3, you may write either 4 or either 5. But if I take a rational number between 2 and 3, then it can be written as 2 plus 3 by 2, which is equal to 5 by 2.
5 by 2.
Got it?
5 by 2.
Got it?
Yes, sir.
Just
Yes, sir.
the examination, if they ask you to find just one rational number between two given rational numbers, you can go for this method, and we call this method as arithmetic mean method or just mean method. And even in the examination, there is a chance of asking more than one rationals. Like find 4 rationals between given rational number, between given 2 rational numbers. Find 6 rationals. Find 8 rationals. Maximum 8 they may ask. So now we are going to focus on finding rational numbers between 2 given rational numbers. So write down side heading. Side heading. Side heading. Rationals between 2 given rationals. Rationals between 2 given rationals. Given rationals. Rationals between 2 given rationals. Right. If A and B are rationals, then a rational number, between A and B is given by, yes, could you tell?
A plus B by 2.
Very good. It is A plus B by 2. That's okay. Now we shall focus on worked example. That is the examples that are given in the textbook. Right. Shall I repeat?
No, sir, 1 minute.
Yes, sir.
1 minute. It is too much. Don't take super minute. Take less than that. If A and B are 2 rational numbers, then a rational number, one rational number between the given 2 rationals can be written as A plus B by 2.
So what is thereafter given? So in the
Yes.
definition, what is thereafter given? What is thereafter the word given? Sir, in the definition, what is there after the word given? I'm not able to understand that word.
No definition is there. So are you asking the doubt regarding this?
Yes, sir, definition. After the
Sir,
word
he's
given.
asking, sir, after given, what is there, sir, that between A and B is given?
Given by.
Thank you.
Given by by.
So why we should take denominator as 2, sir? Why we can't take another integer?
See, here we have 3. Here we have 4. I want just one number between these two, only one number. It is exactly, I am going to take the midpoint of these. What is the midpoint of 3 and 4?
Half.
3.5, right?
3.5.
So
Yes, sir.
that can be found out like this. 3 plus 4 by 2, it is 7 by 2, is 3.5.
7 by 2.
That is
Yes, sir.
if you take 3 as A, 4 as B, it will be written as, the one number is to be written as A plus B by 2. Did you understand?
Yes, sir.
Okay. Now shall I repeat?
Yes, sir.
Yes, sir.
Right. Side heading. Work examples. But solved problems. Right. What examples? What examples? Right. First, find a rational between 8 and 9. Find a rational, only one rational. Have you copied the question?
8.5.
Very good, very good. And let it be in P by Q form only. Don't want decimal. Again, discuss about decimals.
17 by 2.
17 by 2.
17 by 2.
17 by 2.
Right. It is 17 by
2.
2. Yes. That rational number. I'll write. Rational number. Just I'll take this as Q. Or else if you want to write in word, you can write. Rational number. That is equal to. That is A plus B by 2. Two numbers are there. 8 and 9. 8 plus 9 by 2. This is 17 by 2. Overall.
Yes, sir.
This time you should not expect this in the examination. But in the examination, I'll give you the question later. I'll give you that. Second one, please put double star mark, as it is important in the examination point. Find a rational between 3 by 14 and 5 by 21. Find a rational number between 3 by 14 and 5 by 21. Dear students, just observe. Here also we have to follow the same method. I think better to write with you. Right. There are two numbers, 3 by 14 and 5 by 21. Rational number between these two can be written as, right, rational number is equal to, add these two numbers. This is 3 by 14 plus 5 by 21 whole divided by 2. Enough. Hope that you are writing with me.
Yes, sir.
Yes, sir.
Now, this is equal to, just observe. You may stop writing now. Stop writing and look at them. I write the denominator term 2 as it is. Whereas, numerator, it is an infraction. So, it should be simplified. In your previous classes, you have learned how to add fraction numbers. Is it not?
Yes.
So, take the LCM of the
By
denominator.
finding LCM.
What is the LCM?
42.
LCM, very good. LCM is 42. Don't copy. Just observe. 40. The students, some of you are struggling. I can understand that. Here are right. Look at them. 3 by 14 plus 5 by 21. This is equal to, here LCM is, LCM of 14 and 21 is 42. You know that how to find it out. Now, multiply this 42 with first term. 3 by 14 into 42. 14 ones are 14 threes are 3 threes are 9. Multiply LCM with the second term. 5 by 21 into 42.
10.
10.
Very good. 1 are 2 is 10. I'll write that 10 here.
19 by 40.
Whereas 9 plus 10 is
19.
19. So it is 19 by 42. Don't copy, I'll give you time. Now, numerator is in fraction. Denominator 2 by 1 is also in fraction. It should be divided. So to convert that into multiplication, you write like this: 19 by 42 as it is. Take the reciprocal of denominator. What is the reciprocal of 2?
1 by 2.
By 2.
1 by 2. And
1
this
by
is equal to
1 by 2.
19 1 to 90,
84.
84. So this is a rational number. Did you understand?
Yes, sir.
Yes, sir.
Yes, sir.
Therefore,
sir.
a rational number between these two, a rational number between 3 by 14 and 5 by 21 is 19 by 18. It has bit calculation, but this calculation is completely based on your previous knowledge. In your previous classes, you have learned how to add fractional numbers, how to divide a fraction by fraction based on that one. Have you written?
Yes, sir.
Dear students, just listen to me. So as it is beginning, we are moving bit too slow also, because your understanding is important. And second thing is, if you want to move little bit fast, you need to recall your previous knowledge as well. Or else I'll move with the same speed. Okay. Today, what are the concepts we have learned? They are important. Please do practice them today itself. And with respect to today's concept, some questions will be given in worksheets. And in your worksheet, please write your name and also roll number. And worksheet will be sent exactly at 5:30. Again, I'm reminding you, please send within 7 o'clock or at most 7:30. Got it? Okay. With this, shall we stop the class?
Yes, sir.
Okay.
Yes, sir.
Let's meet again tomorrow.
Yes,
Okay.
sir.
Thank you very much. Have a good day.
Thank you, sir.
Yes, sir.
Yes, sir.